We are members of Group 5, showing you the midterm presentation for our client project, City of Orillia, optimization of bus routes. We are a team of three, Ratan Patel being the team leader, Richie George Thomas being the developer, and myself being the business analyst. Our project demands comprehensive data analysis on project count in order to optimize the current bus routes in City of Orillia. We are also required to have a good understanding on urban planning and transit dynamics. Our object is to optimize City of Aurelia's current bus routes by performing detailed analysis of data on bus fares and people counters. These are the tools being used. We're using Jupyter Notebook for EDA and applying ML algorithms using Python, SQL for database management and storage, ArcGIS being the geospatial analysis tool, and MS Excel for descriptive statistics. I'll start by explaining the journey our project has taken in the first couple of weeks. First was sourcing the data, which was stored before pre-processing. We had to clean our dataset before we created the database in SQL. And we started with the Georgian route, one of the busiest routes displayed in the slide over here. So this displays the monthly passenger count in Jupyter before renaming the columns to months instead of dates. Next slide. We did the same for the Georgian route, but for hourly passenger count. Next slide. This is the system architecture design we followed. We had the data source for months and hourly passenger count for each route along with the coordinates. We pre-process the data, which involves cleaning and extraction of important attributes in the dataset. And then we effectively store the dataset after cleaning on MySQL server. And then we started to work on developing effective algorithms to minimize the time and increase ridership. Yeah. So this is the data cleaning on monthly passenger count. This is the slide shows how we identify missing values and null values in the Georgian route dataset. We also checked if the data entry matched the column data type. For example, checking for rows with zero values in numerical columns. Next slide. We performed the same for the rest of the routes, naming the Westridge via Barry, Westridge via Coldwater, LaSalle route, North route. Next slide, please. These are the last two bus routes which we performed data cleaning on. Next slide. Now, this slide represents cleaning for the LaSalle route hourly. We first imported the CSV file and then we removed rows where value under column total is zero. Then we checked for and handled null values using drop now function, which is used to completely drop any rows or columns with null values. And after that, we checked and removed any duplicates before verifying if the data type under each columns are correct and if we convert them to the right data type. We also ensured if any null values are still present in the saved dataset. So this is how the dataset looks like after cleaning. This is the raw dataset on the left hand side and the clean dataset on the right hand side. The database which we have created has 14 tables ranging from bus routes, snapshots, as well as maps, heat maps including. And this is how the clean data set which we store in our SQL database looks like, with every table mentioned here, over here you can see on the left hand side. Ritul will continue onwards with the presentation on activity of 3 and 4 week.
Yeah, thank you, Gokul. I'll start with what we have done in week 3 and 4. So mainly we did the exploratory data analysis for monthly and hourly data, which is shared by the client. And we also explored the ArcGIS in week 3 and in the week 4. So I'll start with the exploratory data analysis on hourly data. So here you can see for Georgian route, we have created the descriptive statistics for hourly basis data. So as you can see, this is the final output for Georgian route, where you can see the mean people count, maximum and minimum people count on hourly basis on overall month, like for all the months and then total. So you can see for Georgian North route, then these two are for South A and South B. These two for Likely route and West Ridgeway Oldbury route. And this is for mostly widely used the West Ridge via cold water route. If I talk about the overall statistics, like route-wise on hourly data, then this is the table which summarizes the overall descriptive statistics. So as you can see, the mean value count is more for WR via cold water, and minimum for South B. So we can tell like the wastage via cold water route is used most. And even if you see the maximum boarding, on hourly basis, then it is also more for wastage via cold water and minimum for South B route. And it is also maximum for Georgian route. We can conclude that Georgian and the wastage via cold water routes are being used most. Then we have converted into the graph to visualize it, visualize it easily. This is the code for visualization, and as you can see that maximum values are higher for Georgian, vestige via cold water route, and the blue are the mean people count, so which is higher for vestige via cold water and Georgian and North route. If you see for South B, then everything is minimum for South B, mean people count, maximum people count. So South B being used less. Then this is the key interpretations for Georgian route, as I explained, the higher mean ridership, uh, and variation is also more. So wide range of variation. If I talk about likely, then a moderate mean ridership. North route is having higher mean ridership. For South A, it's moderate. South beats lowest, as I explained. For Westridge Berry, also it is higher. And for Westridge via cold water, it is very higher for compared to other routes. So this is the important route for us. Then we have created all heat maps to visualize the density of people count during the hourly time. So this is the code and this is the heat map for Churchill route. So as you can see, it is easier around 1 to 4 in the afternoon. These are the heat maps for rest of the routes being same, like very busy around in the afternoon. So this is for South A, South B, Westridge Cold Water, Westridge via Old Berry. Now I'll talk about the monthly data. So we have done similar descriptive statistics for monthly data as well. So this is the code and this is the final output for descriptive statistics. This is the descriptive statistics for Georgian route. Similarly, uh, descriptive statistics for 4 other routes, Westridge via Oldbury, via Coldwater, Lackley, and North route. Similarly for South A and South B. Now I have, as I did for Ali, we have also done for monthly data, like overall descriptive statistics. So as you can see, the mean people count is more for Westridge via Coldwater and less for South B. And even if you see the maximum value is also higher for Westridge via Coldwater and North route and least for South B. And even if you see the total boarding, like total count is also more for Westridge Coldwater and less for South B. And even if you see the standard deviation, then variability is higher for North and Westridge via Coldwater, but is less for South B. So you can tell like Westridge via Coldwater and North are not that much consistent, but South B is consistent in terms of use. So similarly, we have plotted the graphs. So as you can see, we have plotted a graph based on monthly data. So maximum values are higher for Westridge, Coldwater, and North, and mean value is higher for Westridge, Coldwater, and least all the values are least for South B. So this is the summary which I explained about key interpretations from the graph. And then if I talk about, we have also created the heat maps for monthly data as well. So this is the code and this is the overall heat maps for Georgian route. So we can clearly visualize like which stops are being used in terms of used more in terms of ridership. So here you can see Georgian College is used more. And then here also 301 is more in Westridge via Coldwater. 506 stop is having a high ridership. Similarly, for Lackery and Westridge via Oldbury, you can see the stops where there are high ridership. These are for South A and South B. Now Richie will talk about the ArcGIS.
Yeah, thank you, Ritin. So I'll start from ArcGIS map. So we have plotted all the bus stops for the all the routes in ArcGIS. So we can see on the left side we have plotted all the points, And on the right side, we can see, like, if we point to a particular point, we can see the details of the map. Now in activity 5 and 6, we'll mainly focused on route optimization using two methods. One is percentile and the other one is using clustering. Yeah, here the first method approach we have done as 25 percentile method, where we'll omit all the stops having whose passenger count is below 25 percentile. So on the right side, we can see for the Georgian route, the 25 percentile was 440 passengers. So this output basically shows all the routes, all the data, and this is basically the Georgian route map that is filtered with the percentile, and the one below is the original map. Now this is the optimization method for Westridge via cold water. On the left side, we can see all the plots that is pointed, and the right side we can see the one that is filtered based on 25 percentile. And now the next method we used is route optimization using clustering. So basically we have used the method of k-means clustering, where it will cluster k clusters. For example, in our case, we have taken 10 clusters. So it will cluster all the latitude and longitude which are near to each other. So on the right side, we have shown the clustering graph. Yeah, the next part of the clustering is calculating the centroid. So for each of the cluster, there will be a centroid. So that will be calculated based on the code. And then we plotted all the clusters and the corresponding coordinates from cluster 0 to cluster 9. And then the last part was filtering the bus stops based on the clustering and the centroid. So once we got the clustering and the centroid coordinates, what we have done is we have filtered all the bus stops which are near to the centroid. So we have got the list of filtered bus stops. So this in this graph, we can see the Georgian route that is plotted using ArcGIS for after clustering. So the left one is the original map and the right one is the one that is filtered after clustering. So we can see the time difference of 2 minutes. So earlier it was 10.7 and then 10.2 for Westridge via cold water. Also the left side is the original and the right side is filtered on the basis of clustering. Also we can see a drastic change in time in both the cases. And talking about the project hours, we have calculated our budgeted hours and the actual hours. So we have basically phases which includes requirement, design, development, testing, and release. Since we are done with the requirement and design, we have included the budgeted hours and the actual hours. Since we are on the development phase and the rest of the future phases are still pending, so we haven't calculated the actual hours, or we plotted the budgeted hours as well. And this is the cost, project cost for budgeted versus actual. We can see all the four phases. And the basic challenge which we face for the project is how to optimize using clustering. So we know that machine learning algorithm works for a problem statement, but we are also looking for different approaches as well. So our solution is to look for any kind of algorithm that will give like better approach to solve this problem. And the current recommendations which we have is like combined clustering, where we'll plot all the routes, we'll plot all the routes together and we'll cluster as a whole to see like if there is any change with the current method. And the second recommendation is hourly based analysis. So that will be we'll be checking for hourly basis for all the routes. Now I will share the screen for the live demonstration. So as you can see here, uh, this is the cleaning and statistics of the data for all the routes. So first cell contains the clean data and the second cell contains the statistics, will show all the statistics for all the routes. And then we have done is heat maps, where we have added the code for generating the heat map for all the routes. And this is for Georgian route. And then the next part is clustering. So route optimization using clustering. So as I mentioned in the content, so I have plotted all the coordinates and clustered, and this is the filtered routes. Now I'll share for the maps as well. So this is the original map of Orillia of the Georgian route, and then this is the optimized version, uh, and then this is for vestige via cold water, and this is the filtered one based on the clustering. Now Ritin will continue with the presentation.
Yeah, thank you, Richi. Now I'll share the screen. Thank you, Richi. So as I explained, like as Richi showed for hourly, this is the same for monthly data, like all the cleaning and the statistics. So you can see the code for all the statistics, and this is for 25 percentile route method, like to identify the stuff below 25 percentile. And here you can see the map for Westridge and the Georgian. So this is for Westridge and this is for Georgian. And this is, as we mentioned, like we plotted all the stops on the map. So that's about the today's presentation. Thank you, Professor. Thank you.